problem. Okay, it's about the parabola, no? Parabola. Remember, let me recall quickly. Do you see my whiteboard? Yes or no?
Yes, Professor.
Cool.
Yes.
Okay. So we have different conic section. The first one that we studied was ellipse. An ellipse, you identification perfectly because our equation contains x squared, y squared, and the cooperation between them is plus. And parabola, no. Parabola is x squared and y no square, or y squared and x no square. You see the one is linear, another is square, and the sign is not important, plus minus. This is a classical parabola. We have 4 kinds of parabola, no? And the hyperbola that we studied in a few seconds is very similar to the ellipse. It's x squared, y squared, pero minus in between. That's it. It's the identification. After that, well, you try to do your best doing algebra in order to express the given equation, que normally is confusing, to a standard. So for example, in the example 4, we have this equation. Wow, what the hell is that? And you need to manipulate in order to express in a standard. So you recognize, number 1, you recognize is parabola because x is square and y no square. What kind of parabola? Well, very good. So my parabola look like, I don't know, something like that. Oh, like that. That depends on the p-value que I obtain. CP is positive. It's over, open over. CP is negative, open down. Okay, but let me try to manipulate algebra, the heavy algebra, to obtain a new equation equivalent 100% to the original. However, look like similar to this format, que es estándar. Okay, so I propose this situation. I take the x part separately to the y part. And the coefficient 57, I recommend move to the right hand side. So you take the x part. The x part, I can see, wow, 4 is common factor. X squared minus 5x. I suppose that I need to complete the square. I put a box. Remember the box, you put inside the magic number that complete the square, right? Now, that part look like similar to this part. So now I recommend that you moving 57 to the right hand side, or minus, no? Plus AY, plus another box, que not necessarily is the same to this number, because remember we have factor 4 here inside. How you find the magic number? Question mark. You take B, get 5. I don't care the sign. The sign is not important. Say positive or negative. You divide by 2. Always divide by 2 and square. So solve get 5 squared get 25 and 2 squared get 4. So the magic number now is 25 over 4. And when you are doing this action, unbelievable, this trinomial is converting to the perfect square trinomial, and the factorization is too easy. In order to keep the equilibrium of the equation, of course, you need to put extra number here because I put artificially one crazy 25 over 4 on the left-hand side. I need to do, pero no 25 over 4. Don't forget that 25 over 4 multiplied by 4 is 25, and you put 25 here. Do you follow me? This is the most complicated part. Do you follow me or no? Answer me. Hey, are you there?
Yes,
You
I follow.
Okay, cool. Now. This is the beautiful part. So you bring down 4, I know that this trinomial is perfect square and the factorization is x minus square root that guy, get 5 over 2 square. Okay. So welcome from 5 over 2 is square root 25 over 4. So square root 25 over 4 is square root 25, get 5, and the square root 4 is 2. 5 over 2 or 2.5, it's the same. It's square. Now on the right hand side we have AY. Okay, I understand that. And you subtracting negative 57 and 25, and the answer is negative 32. Okay, I like that. Now compare this equation and this equation. Well, in this equation, the coefficient here is 1. Therefore, I need to remove somehow that 4. So you divide by 4, you divide by 4, you divide by 4, and so far we have x minus 5 over 2 squared is equal to y minus 8. Okay, cool. In that case, I have to do the last step in which I can see all we have ever in this case happen. Okay, you factor out 2 here, no? Because it's 2y minus 4, right? Now ready. Please compare this equation and this equation. I want to recopy again. It's a standard now. Okay, because I can see clear. Okay, h is 5 over 2. And k, because this guy is 4, positive 4. So the vertex of this parabola is located at the point 5 over 2 or 2.5, either way, comma 4. This is the vertex. Beautiful. You want working with the decimal 2.5 to feel better, more clear, more understandable, because 5 over 2 some students don't understand very well or don't see very well. Now this is the vertex. So in what direction open that parabola? Well. Let me try to find P. So now I see that 2 would be equal 4P. Therefore 2 is equal 4P. Divided by 4 both sides, because I want to isolate is P is equal to over 4, okay, reducing lowest term at 1/2. But it's positive. It's positive. If it's positive, my parabola open over. It's obvious like that. So you discard this possibility. No, downward, over. From this famous point is this. The rest is easy. The focus is inside here. That distance is P. Directrix is in the opposite direction. It's a line like that. The endpoint of the focal diameter is in this distance, 2P to P. And the symmetry is this axis, okay, is vertical line, x equal something. That this something is always h. Okay, h is 2.5. But you don't worry too much for the graphic, because you put in decimals. I suppose that you see the link that I sent to the specific script of the decimal that I create for my students. Okay, you set up HK and P, and you see perfectly any point of the hour per hour. Do you see this link or no? Yes or no? Let me try to share. Switching to decimals. Okay. Do you see decimals? Do you see decimals? Yes or no?
Yes. Yes, we do.
Look, I copy. It's example 4. I copy the equation. The equation exactly the same is given at the beginning. I got that. I put it all able to see, and you see que es the parábola. And you see the vertex. Oh, it's coincident with the point 2.5, 4. However, if you want to see the other detail of the graph of parabola, guys, in the test, one question of this: parabola, ellipse, hyperbola. I see the graph in detail. Therefore, I highly recommend you using this script. You open that, it's yours, it's my copy. Si you don't have, you email me, I resent. Entonces, now, who is, in the parábola, the only parameter que I need to set up is h, que es 2.5, 2.5, k, que es 4, okay, pero positive 4, not negative 4, positive 4. It's important, the signs, it's crucial, the sign. And the p was 1/2. You put it like a fraction or like a decimal. I don't know why I like decimal, 0.5. 0.5. Entonces I classify que our parábola in our problem was or is vertical parábola. Bang, and you see anything? You see vertex 2.4, 2.5,4, focal 2.5,4.5, endpoint of the focal diameter, symmetry axis, and eccentricity. Okay, the line y equals something, no? Y equal 3.5, I guess so, no? Because it's in between 3 and 4, it's 3.5, absolutely. And the vertical line que es symmetry is obvious que es x equal 2.5. Que es the first component for the vertex. Everything is clear, guys? Sure? Do you understand? Come on.
Yes, Professor.
Okay. Let me try to come back to the whiteboard again. Okay. Now let's do an example of the hyperbola. Let me explain first of all the theoretical part of the hyperbola. Do you see my whiteboard or not yet?
Yeah, we can see it now.
Perfect. Okay, we have two kinds of hyperbola. Hyperbola. You recognize, remember, because it's x squared, y squared, and minus. Not necessarily like that, it may be like that, y squared, x squared, minus. But depending who is positive, okay, you have two kinds of hyperbola. One hyperbola can open in that direction, okay, one to call horizontal hyperbola. Okay, another hyperbola can open in that direction, okay, I call vertical hyperbola. The most important is okay, what this axis, okay, by the way, is called transversal axis, is parallel or coincident with the x-axis when it's horizontal. And this is parallel or coincident with the y when it's vertical. How do you know? Look at the equation. Well. So you see the equation like that. X squared over a squared minus y squared over b squared equal 1. This is a standard. This corresponds with this. However, this is different. It's y squared over a squared minus x squared over b squared equal 1, corresponding with the back, in which the transversal axis is parallel or coincident with the y-axis. And something is weird, I want to emphasize. Okay, this is completely different to the ellipse. That your brain is adapted with the ellipse in which in the ellipse A is the bigger, right? Than B. No. And the hyperbola, no. And the hyperbola A is the coefficient C associated always with the positive part. Look at that. Si es corresponding with the x, entonces horizontal hyperbola. CSY is spherical hyperbola. That's it. However, one more information, one more that we need to know. We need to know that we have focus, two foci in plural. Let me use it for the foci blue color. Que es obvio que es similar to the parabola, no es inside. It's a foci, two foci, F1, F2. In that case, is here. Doesn't matter who is one, who is two. The order is not important. I call F1 F2 to call different name. Now, one important. The hyperbola have two slant asymptotes. Asymptome like that. Look, let me show you. Let me try to do my best. This sketch is not good. Look, pam. So we have center. Okay, cool. Center, yes. We have asymptote. Don't worry too much for the asymptote that I want to explain now. And the hyperbola, que horizontal, look like that, passing through the vertex. Sorry, not the focus. So we have vertex here. It's in focus in blue. And asymptotically approach it asymptotically. Asymptotic means, remember, the asymptote is, let's say, hypothetic line with the curve approach it, but never touch this. No. I don't do it well. Never touch. Approach it asymptotically. But the distance is decreasing, but never is zero. So the equation for the asymptote, this is y minus k is equal plus and minus b over a parenthesis x minus h. I don't know why in any books it's expressed the equation of the asymptote in this way. This way corresponds the guy to the point slope. Point slope formula of the line. Okay, I recall quickly is y minus y1 is equal slope parenthesis x minus x1. So it's the formula that allows us to find the equation of the line when you have two pieces of information. You have a slope and you have 1 point. Okay, it's x1, y1. So in this case, it's similar. It's similar. You have a point as the center of the hyperbola, h, k. It's x1, y1, and its slope is b over a, because, let me try to make another more accuracy sketch of the hyperbola. Look, to do the graph of the hyperbola in detail, we need vertex. Vertex, let me use in black color. Suppose que horizontal. Hypothetical, horizontal. Horizontal hyperbola. Okay, this is vertex 1. This distance is A. This is vertex 2, totally symmetric. This distance is A also. We have foci in blue, I remember, but it's a little bit bigger. Foci 1, foci 2. Now, what is the play with this distance? As always happens, is C. And what is the relationship ABC? Is the same of the elixir, professor? No, it's another formula. Same formula or similar, but not the same. In this case, C squared is equal A squared plus B squared. This is a hyperbola equation. In elixir, no. Elixir was, I want to copy. I don't want you to confuse it with this. A squared is equal B squared plus C squared. Because in the lib set, the big segment is A. And the hyperbola, no. The big segment is C. And what is the place of the big? I don't see B for any place. Well, B is located in the perpendicular direction B. And you connecting the center, get this. The center, guys, in general is the point H, K, no? In general. So you form a little bit one rectangular, que it's easy, because you have the dimension of the rectangle is AA, BB, this rectangle is called reference rectangle. And this reference rectangle allow me to do the diagonals, and the diagonals help me to do the sketch of the acetone. You connect the center and any corner of the reference rectangular, and you get the acetone. And the acetone obey to this equation. And the horizontal and the vertical is a little bit different. You don't worry too much with the reference rectangle because in my script, the Desmos, immediately you can see. Now my horizontal hyperbola look like that, passing through the vertex, asymptotically this, asymptotically to this. Passing through the vertex, asymptotically to this, and asymptotically to this. End the story. That's it. And the vertical is different because the transversal axis is coincident, parallel or no with the y-axis. Okay, let me integrate everything. Okay, I know it's too long, confusing. To the example, no? 3 examples. I bring 3 examples today for that. Let's do it. Let me move a little bit to this. Example 1 of the hyperbola. Example 1 of the hyperbola. Okay. Example 1 always is easy. You have x squared over 4 minus y squared over 9 equal 1. Oh, it's a hyperbola. I know, because the professor explained me that when this x squared exists, okay, sorry, here, exist x squared and y squared, and the sign is minus, okay, it's a hyperbola. It's totally irrelevant, the coefficients we have here, it doesn't matter, it's not important. Okay, and also it's already expressed in standard. Nice. How do you know that? Because it's right-hand side 1. Now you compare this equation and this equation. We have another alternative, que is like that. But no, it's no, because the positive part corresponds with x. So actually, it's this. In other words, our hyperbola look like that because the transversal axis is parallel or coincident with the x-axis. But the positive part is associated with the x part, and the negative part, no. So this is the clue que give me information. So I know this transversal axis exactly in this case on the x-axis. Entonces it's easy to understand that the center of the hyperbola is located in 0, 0 because I don't see any h, any k. This equation you can modification a little bit, include the displacement, the shift, like that, y minus k squared. When you don't see any k, any h, entonces es obvio que es 0, 0. O sea, this equation is equivalent to this equation. And the same idea que you suppose que h is 0 and k is 0. Center is 0, 0. Nice. This is my hyperbola here, 0, 0. Origin. Now a squared 4. Don't confuse it, please. Because in the ellipse, you suppose that the big number is 9 is 8. No! In the hyperbola, the a is the positive and b is the negative. Therefore, a is 2. And b squared is 9. Therefore, b alone is 3. Okay. If you want to find c, okay, let's do it. The equation is c is equal to square root a squared plus b squared. Entonces es square root 4 plus 9, 13. And square root 13, unfortunately, 13 is prime number, and the square root prime number is irrational, but it's okay. It's 3.606. You put in the calculator. Okay, let me try to do roughly sketch by hand. And after, of course, as always, you doing in decimals. No? And actually, in the test, you are doing in decimal and send me a copy. You know how you send me the copy, no? Some people say, no, I don't know how. You don't know. I explained several times here. Let me try to do my best. I found a piece of paper with a rectangular coordinate system, maybe. There you go. I put in my whiteboard. Okay, so I discover in this problem que our hyperbola is horizontal. Cool. I discover also que A is 2. Therefore, I plot the vertex. Okay, the center, sorry. The center is in 0, 0. It's the center of this hyperbola. But the vertex is in 2 and negative 2. This distance is A. 2,0 and negative 2,0. And in order to, well, the focus is too fuzzy. Let me try to use in blue color. It's 3 point something. It's in between 3 and 4, close to 4. This is the fuzzy, and this is another fuzzy. Fuzzy 1, fuzzy 2. This is vertex 1. This is vertex 2. And this is just the center. In order to do the reference rectangular, you plot B. B is 3. B is 3, right? Yeah, B is 3. Entonces 3 is 1, 2, 3. Okay, this is 2 and 3. We have the corner of our reference rectangle using A, B, B. Down. B, B is 3. And this is my reference rectangle. And you connecting using the rule. The corner of the reference rectangle passing through, of course, by the center. Let me try to do my best. Something like that. Not exactly, but something like that. Of course, asymptote, any asymptote, you know, you put dotted line. Off, dotted line. Now I rotate. Another dotted line. Okay, cool. Another dotted line. Okay. Now, ready to do the sketch of the curve of the hyperbola passing through vertex. Open right and left because it's horizontal. And asymptotically approaching asymptotically to the asymptote of this. You see much better in this one now. Like that. Like that. Does it? No. Why not? Because I need another piece of information. Okay, the equation of the asymptote. Remember, the equation of the asymptote is, in this case, horizontal, is y minus h is equal plus or minus. Why plus or minus? Because you have two asymptotes. One asymptote can have a slope positive, is this, and one can have a slope negative, is this. No? B over A, x minus h. No? It's the general equation. However, h and k, the k, sorry, is 0. So actually, it's y is equal plus or minus b. Who is b? B is 3. Who is a? It's 2. 3 over 2. It's a fraction. And x. End the story. This is the equation of the both asymptotes. Of course, this asymptote is y equal positive 3/2 x, and this asymptote is y equal minus 3/2 x. Boom. That's it. No more complication. Let's try to show you in decimal how we are doing this. Okay, now. I share decimals. Switching. Decimals. Hyperbola. Hyperbola now. Okay, entonces en our specific example, do you see decimals? Yes or no? Let me delete that part. Let me delete that part. Okay, our example is number 1, and the hyperbola is this. Oh, it's easy, look, because it's expressing a standard. Look, 2 branch, hyperbola. Hyperbola. Do you see decimal guy? I want to make sure. Yes or no?
Yes.
Cool. Now I discover in the piece of paper que A is 2. B is 3. Ready. But H and K is 0. Is 0. The category of this hyperbola is, oh wait, the hyperbola is horizontal, no? Yeah, there you go. Bam! You see magically. Look at that. What? Repetition again. Okay. We have the center and blue and green color. We have the vertex, I suppose que es purple color. We have the focus too, because it's plural, and blue color as always. And you have the corner of the reference rectangle, and you see the accent. Wow, elegant accent. Let me enable this part. This is the classical equation. When you write the equation like that without details, but I need details, you know? The detail is no. You click here to see it. Remember, so now when you get the answer, you go to this tool. No. What is that? Here, this tool. Is this? I don't remember now. Is this? Is this? And export. Export the picture. Wow, look at that, beautiful. And you select what size you like, si it's medium or it's large or it's small, whatever. And you upload this picture. And you show me. And the story. Okay, another possibility is make a screenshot. You know how you are doing a screenshot. Yes or no?
Yes, Professor.
Any question about hyperbola? Of course, this is a kindergarten example, no? That's the first one. Es elementary example. The first one is always elementary, pero it's important to illustrate the details of the hyperbolic I need to see. Okay, switching to the whiteboard again. Let's move on to the second example. Second example. There you go. I want to rate everything. Second example. Second example is example 2. Look at that. Wow. It's nice. Is 16y squared minus 9x squared equal 144. Wow. ¿Es hyperbola, yes or no? Oh, yes, it's hyperbola because the teacher explained that when there exists x squared or y squared, doesn't matter the sign. The sign is not one of the sign important to classify as hyperbola because it's minus, no? But obviously, this equation is not already expressed in standard. Because in standard, we need right-hand side 0. Suppose that this equation, when I finish the manipulation, no? Is something like that. Okay, it's important que standard right-hand side is 1. Entonces you divide the whole thing by 144. 144, 144, 144. Entonces you put in the calculator 144 divided by 16 is 9. Where come from 9, guys? Was 144 in opposite, totally reciprocal. Because I want to put the number in the denominator, not in the numerator. Okay, entonces es un 9. Minus, likewise, 144 divided by 9 is 16. Okay, cool. Entonces x squared over 16 equal 1. Now already this equation is expressed in standard. Okay, it's exactly I need to start the analysis. Entonces we have two possibilities. One hyperbola the teacher explains is like that, another hyperbola the teacher explains like that. What do you think, horizontal or vertical? It's a challenge. It's a question. Tell me. No idea?
I think it's vertical.
You are right. The reason is clear. Because the positive part is associated with the y part. That is the reason que es vertical. So the famous transversal axis is coincident or parallel to the y-axis. Okay? Cool, it's vertical. Now my next question is now. Who is A? A square. And who is B? A square.
A squared is B squared.
Repeat again, I don't hear.
A squared is B squared is.
The last part is the important part. I don't hear. You say A squared is mute, B squared is mute. Another guy can help to him. Who is A squared?
9.
9. And B squared is 60. This is the okay. You have 50-50, no? Remember, one more time, I repeat the idea. A squared is associated with the positive part in the hyperbola. Totally different to the ellipse. Totally different. Because in ellipse, both are positive. Then A is 3. Square root 9. And B is 4. Okay, cool. And by the way, the center of this hyperbola is located again one more time in 0, 0. In 0, 0. Because I don't see any shift here in X and Y. No, H and K is missing, right? I need to determine C. C squared is equal to B squared or A squared plus B squared. Completely different equation from the ellipse. And 9 plus 16 is 25. Therefore, C alone is square root 25 is 5. But the focal distance is 5. So basically, let me try to do quickly. This is the center. Boom. This is the vertex is located in the y-axis because of vertical. So it's 3. 1, 2, 3. This is one vertex. 1, 2, 3. This is another vertex. Vertex 1, vertex 2 would be 0,3, 0,-3. And the focal is always I use in blue color. Here, focal 1, focal 2 is in 5, no? Positive 5, negative 5, pero it's on the y-axis. Entonces, any point on the y-axis is 0,5 and 0,-5, no? And the endpoint of the, B, sorry, no endpoint. B is 4. So now it's useful to make a reference rectangle. It's 3, 1, 2, 3, 4. 1, 2, 3, 4. This is B. And our reference rectangle look like that. And our ellipse, our hyperbola, sorry, I'm crazy. Oh, no, sorry. And now I'm doing the ascendant, connecting the center and any corner of the reference rectangle. Now ready to do the graphic of the hyperbola, que is from the vertex asymptotic in that direction. for the vertex asymptotic to the other direction. It's easy. You think it's easy? You need to remember some detail, but it's relatively easy. Let's try to see in Desmos now. In Desmos now, let me show you. Okay, I want to share the screen, Desmos. Exactly. I suppose you see now this, right? But not this example. No. Example 2. No, this was 1. Now 2. Look at that. 2 is 16. I copy. You see this, guy? Yes or no?
Yes.
Yeah. I copy without modification. I copy exactly the same as given. I copy, wow, because I have no idea. But I see, wow, it's vertical, hyperbola. However, I go back to the double checking, no? To verify que the thing que we are doing in the piece of paper is cool or no. Entonces, A es 3, ¿no? A es 3. B is 4. You don't care for the C because the script, so the equation behind this script compute automatically C and plot the focus. And you classify like a horizontal, no vertical hyperbola. Bang! Look at that. This is my hyperbola. Center 0, vertex 0,3, 0,-3. Focus 0,5, 0,-5. By the way, I want to say something again. I suppose I saw, but I don't remember very well. So the focus, the foci too, lie in the transverse axis. Okay? It's the same axis in which lie the vertex. And B, no, B don't participate in the game, only participate to do only the reference rectangle. You connect to the corner, you have the asymptote, and you see how, look at that, it's amazing. The hyperbola approach it, but never touch. Asymptotically, look. The distance decreasing, but never 0. Do you see? Okay, one more example, complicated, of course. Similar to the thing I want to put in the test. Okay, but you don't worry because we have these tools. Okay, everyone using this tool. This is crazy doing by hand. I do but for my student, no? I suppose you appreciate so much this or not? Okay, let me share one more time the whiteboard. Do you see my whiteboard? Okay, by the way, I erase. Do you see or not?
Yes.
Okay, example 4. Example 3. I want to reduce the lecture because I need to start new topic today. I call it 3, but it's okay. This is 11x squared minus 2y squared plus 66x minus 4y plus 75 equals 0. Wow, what the hell? Don't be scared. Okay, this is an equation of the hyperbola. How do you know? Because we have x squared and y squared. I don't care the coefficient 11 and 2 and minus in between. This is the clue que give me the idea that this is a hyperbola, and by the way, this is a horizontal hyperbola because x is squared, right? But the rest is algebra in which you need to put together somehow the x part, this and this, and put together the y part. And 75 always I move to the other side. This is the organization. Look, let me show you. You copy now. 11 x squared and 66 x. 66, not 6. This is a square, it's linear. But I say, wow, wait a second. I saw que 11 is a common factor. So you factor out 11. You have x squared plus 6x plus and the box can help me to complete the square. Likewise, we are doing in the y part. But in y part, I see that both guys are negative. Okay, no problem. Do minus 2 outside. We have y squared plus 2y, because 2 times 2 is 4, plus another box to complete the second perfect square trinomial. No? Entonces, entre the right hand side, I have minus 75 plus 2 boxes. And not necessarily the boxes is the same, but they are equivalent. Okay. Okay, I am ready now. Do you understand the organization, guy, or no?
Yes.
Yes. Now. Remember the same rule, the magic number. You take b, get 6. Divided by 2 square. 6 divided by 2 is 3. 3 squared is 9. This is 9. You take that number, b, get 2. Divided by 2 and a square. 2 divided by 2 is 1. Square is 1. Bam, is 1 here. 1 and 9. Okay, now, wait. I need to complete here that number and that number. Well, that number is, I suppose it's 99, because 9 times 11, no? It's 99, yeah, it's 99. This number is 99. Because I introduced artificially that 9, but actually it's not 9, it's 9 times 11. And in the second box, it's obvious that we have minus 2, no? Because you put artificially one positive 1, but positive 1 multiplied by the negative 2 is negative 2. So actually, the number I introduced artificially in the left-hand side is not 1, it's negative 2. In order to keep the equilibrium, well, okay, you put negative 2. And so now I am happy, because this is 11. The factorization is x plus 3 square. 3 is square root 9 minus 2 y plus 1, because the square root 1 is 1. In the right hand side, we have 75 negative, and minus 2 is negative 77, and 99 minus 77 is 22, no? 22? Yeah, it's 22. Okay. I finish. No. Why no? Because I need, remember, in the right hand side, the typical standard is when there's 1. So you divide by 22 here, you divide by 22 here, you divide by 22 here. Okay, now finish. I almost finished. 22 divided by 11 is 2. X plus 3 squared over 2 minus y plus 1 squared over 11, que es the division 22 divided by 2 equal 1. Nice. Wow, amazing. This equation, guys, is equivalent 100% to the ugly original equation. Can nobody understand? Nobody understand this. Equivalent. So you are doing putting decimal this equation, and you put it in decimal this equation. I am doing by curiosity. It's the same. It's the same curve. It's the same hyperbola. But in this case, you don't understand anything. However, in this case, you understand everything. Because the center of this hyperbola is located at the point minus 3, minus 1. Let me check it. Yeah, minus 3, minus 1. I see a squared 2, therefore a alone is radical 2. It's a weird number. 1.41 something. Okay, this is the reason, guys, because sometimes to make a sketch by hand is crazy. Therefore, we need a graphic calculator. And a special graphic calculator que I create for you. A b squared, sorry, is 11. Now, b alone is the square root 11, que is approximately 3 point something. 3.3. 3.3. 1106. You can verify in your own calculator. And C squared is the sum 11 plus 2, okay, 13. Therefore, C alone is square root 13, okay, is 3.605. This is the focal distance. This is the distance for the vertex, and this is the distance to build the reference rectangle. And it's located from the center, is this. Okay. The equation of the asymptote, well, is y equal y minus k is equal plus and minus p over a because it's horizontal, x minus h. In our specific example, is h is minus 3, k is negative 1. Okay, no problem, I understand. Okay, let me make a zoom. Y plus 1. Yeah, because k is negative 1, so the double negative becomes positive. Plus or minus, so this is a weird number. This is, but no, let me write an irrational number. B is radical 11, A is radical 2. X plus again, by the same reason, 3. Bam! And this is the equation of the acid. Let me show you on decimal, and that's it. We have limited time for finish the semester. However, I am doing similar idea I did before. I have the review package, and the solution for the review package is given in the YouTube video. In your moment, I will send the review package in PDF paper, electronic paper, no? And send the link connected with the solution, and you can see. The only problem is you spend time watching the video, right? Sorry. It's the only possibility. Okay, let me show you the graphic in decimal, and that's it. No decimal anymore. Okay. Now decimals. We are doing the example I call number 3. However, no number 3 and decimal is number 4, but it's okay. It's totally real. I skip one because I need to gain time. Suppose number 4. Bam! Look at that. You see decimal, no? My computer indicated yes, but I need to confirmation with you. Yes or no? Yes. Look at that. It's the original is given. I copy. I plot that. Bam! However, it's expecting is horizontal hyperbola. However, I want to, by curiosity, I want to copy in the standard I computed before. Okay, was, let me try my best. And my keyboard, no, and the decimal keyboard is better. And the decimal keyboard is better. You have parentheses, x plus 3. Close the parenthesis. Oh, no, coño, what are you doing? And the other line, enter. Okay, yeah, ready. Es parenthesis, x plus 3. I try to copy the standard, no? X plus 3. Square outside square divided by 2. Remember, k square is 2. Now I put minus subtraction hyperbola. Again, parenthesis, y plus 1, okay, square again, divided by 11. Equal 1, because it's a standard right hand side, I create 1. But you see, okay, I put intentionally in blue color, no? See, I delete, for example, delete, no, I put on enable. You see the red one, look, And this is, you see it's the same? Guys, the beauty of this is that the thing that we are doing algebraically to put the equation in standard is equivalent, it's the same. It's the same equation, but in different form, different shape. But no, I want to delete that because I want to use in the double checking as always. So A, in our example, A is radical 2. Ooh, radical 2 is weird. No, it's okay. I delete that. I put radical 2. Look in the keyboard of decimal. I have square root 2. You see here it's 1.4142. B is radical 11. Don't type in the decimal because you lost approximation. And H and K was, H is negative 3. Negative 3. And K is negative 1. Negative 1. Now I classify this hyperbola like a horizontal, no? Bam! And you see everything clear. You see now the center here, vertex here, foci here, and the famous reference rectangle and the corresponding asymptote. Beautiful. Coincident perfectly with this. Let me flash this red color. By coincidence, the mathematical behind this is red color also. Let me switch it to another color, maybe black. Okay, cool. So now it's black. So the hyperbola doing using details is a black, and the other hyperbola que no detail is red. Black, red. And you see que it's a combination of black, a little bit darkness, you know? Let me remove the black, the red. No red anymore, entonces black. Super clear or super confusing? Clear, I know. Of course you have to practice, no? That is the reason that the homework online is waiting for you. Homework online is waiting for you for the comment sections. Guy, any question you have? You never know, sometimes use it, but the majority of students, I don't know, have shape or shy and don't using me in the solution for any. I can help in the homework and the test, no. So I detecting it because I know by memory what is the question for the test and what is the question for the homework. Okay, do you see my whiteboard now or not yet? Let me try to verification. See, I share whiteboard. Yes or no? Do you see or no? Do you see or no?
Yes.
Yes. Okay, sequence is the next topic. What is that? Well, it's easy. Sequence is a list of the number. Sequence is a list of the number. Separate by comma. Suppose. So this is a function. It's a function, but important of the function is the domain is the natural number and connecting by the real number. For example, what is the natural number? What is the natural number? Es the set que está en 1, 2, 3, and so on. 4, 5, to infinity. Real no, real is continuous. O sea, now the domain, o sea, the value of the, no, it's not x, it's m. And the word of the sequence is m. It's a natural number. For example, let me show you. Suppose it's given the equation for the sequence. A sub n is the explicit formula of the sequence. Suppose one hypothetical example. You see a lot of examples. Suppose n minus 1 divided by n. This is the explicit formula. So I ask you, okay, try to do at least 3 elements in the sequence. Okay. A is 1, plugging in 1 is 1 minus 1 divided by 1 is 0. A sub 2, just replace n for 2. 2 minus 1 divided by 2 is 1/2. A sub 3 is 3 minus 1 divided by 3 is 2/3. Let's do one more. A4 is 4 minus 1 divided by 4 is 3/4. Our sequence, you can express it like that. 0, 1/2, 2/3, 3/4. And this continues forever to infinity. Pa, pa, pa. These 3 points indicate it continue forever. This is one possibility. Another possibility is right like that. The explicit formula. A sub m is n minus 1 divided by n. Cool? Easy. However, we have sometimes it's useful the summation of the sequence. So we're using now summation notation. Summation notation. Okay, summation notation, guys, is super important in calculus. And to represent the summation notation, we need the sequence, of course. But you need one special symbol, que es a Greek letter, sigma, capital sigma. I don't know if you see before, it look like that. Sigma. This is summation notation. Inside the summation notation, you copy the explicit formula of the sequence. Okay, you want to add addition, A sub m, or no sub m. Well, the different letters we use in DSM, or is K, or is I, or is J. This is the typical letter we use in mathematics to the summation notation, but also okay, n is okay. Entonces now you copy down the lower bound, que es suppose que es 1, from n equal 1 to another number, suppose 5. This is equivalent the condensing way to express the A1 plus A2 plus A3 plus A4 plus A5. Because the first number is this number and the last number is this number. So this is the upper bound and this is the lower bound and the summation notation. Do you understand very well the idea or not? Let me try to put a couple of examples to illustrate very well the format for the summation notation. Okay, suppose example 1. All right, Control C. Okay, suppose this. Okay. Suppose, okay, I want to, example 1, easy. Summation notation from K, I like so much K, like an index variable of the summation, index variable from 1 to 5 of the one sequence case 1 over K. Ooh, expand this. So this is the condensing way, and you expand. Well, okay, you evaluate 1, get the first 1 over 1. Next is 1 over 2. Next is 1 over 3. Always is natural number sequence 1 over 4 and 1 over 5, 1/5. So actually 1 over 1 is 1. Not necessarily right like that. Stupid. It's just 1. Boom, I finish. Expand. I expand from summation notation to the sequence separated by plus, no? Expand. Let's do it now in complete opposite order. Suppose I have example 2, and we say given a summation, but no in summation notation, it's given in the natural way. 1 square, 2 square, 3 square, 4 square, plus plus 9 square. Entonces, what is the goal? The goal is condensing using the summation notation. Entonces, you put a sigma I discovered the explicit formula for that sequence, que obviously is k squared. Bueno, si I like the letter k, suppose another two say, no, I don't like k, I like m. Okay, no problem. You put n squared, and n vary from 1 to 9. Wow, at least it's equivalent mathematically to this long way is short. Takada. Okay? Now, I want to explain. Do you follow me?
Yeah.
I want to explain the different notation, the different, property. Guys, the summation notation is super useful in calculus. Calculus 1, basically. And calculus 2 a little bit, but calculus 1 specifically. When you take calculus 1, guys, next semester? Summer or you waiting for the fall? Or you don't need to take that? To the fall, okay. Now, I recommend to the fall because this class is 5 credits, 5 credits. It's like my class. It's hard, it's long, complicated. And you need to understand very well this algebra and trigonometric. Okay, let's study now a property of summation. Property, the summation have different properties of summation notation. Okay. We have 1, 2, 3, 4, 5, 6, 7 property. Okay, look. Property 1, P1. When you have summation, suppose k from k1 to m, and inside we have a constant. C is a constant. Constant is just a number, 40, 20. Multiplication by the explicit formula for the sequence, que is a sub k. Well, the thing that you should do is factorization. You put outside. One example to understand this. I am doing 3,000 example, guy. But no, it's not important too much. But this example, I would like you to understand very well. Suppose you have summation from k equal 1 to 20 of the 5k. Okay, to say this is a sub k, but 5 is a constant, like a c. So 5 is analogous to the thing I tried to illustrate in the property. And you factor out. You put outside. 5 sigma k1 to 20 of k. And let's see what happened in that part. No, not yet. It's another property I want to study as the property number 5. But this is the one. So when you have a constant, 2, 3, 4, whatever, you put outside the summation. If you want, so you consider it good. If you don't consider it good, okay, stay inside the summation. Property number 2, easy to understand. Suppose you have summation. But inside we have two elements, two terms. AK plus and minus, maybe positive or negative, addition or subtraction, but you have two sequences, A sub k and B sub k is two separately sequence, you can split. You say, well, professor, but this is logical. Well, of course it's logical, but I need to explain. Okay, to say Caesar, in my opinion, compute separately, cannot together. Property 3. Oh, property 3 is very confusing, but useful. Suppose now, can we have summation from k equal 1 to m of a sub k, only one sequence, and you split into summation. How? Well, the first summation go from k equal 1, get the lower bound, exactly the same, to the one hypothetic number m. Who is m? You have 1, you have m, and m is in between, in the middle of this. So you have two summations, summation 1 from 1 to n, and summation 2 from n to m. So a sub k is the same, but here k no go to the m, go to the m plus 1, because it's the next guy. No, you are doing the summation And the first summation gets this summation 1 from 1 to m, and you set up the summation 2 from m plus 1 gets the next guy to m, summation 2. It's obvious, right? This makes sense. This is super, but I need to clarify this. Suppose hypothetical one example. Suppose that I'm doing summation, example to illustrate, because maybe it's confusing with a letter M, N, what the hell? Suppose that I have one hypothetical example in which you have the summation from k equal 1 to 100 of the a sub k. Remember, a sub k represent, guys, the explicit formula of the one sequence. Okay. Suppose that I split like that into summation. The first summation is starting 1, and the first ending in, I don't know, 80. Because I need 80. This is my convenience. And the second start in 81 to 100 get the last. It's okay. Do you understand this? And what is the reason guys select 80, Professor? 50, 51. It's the same. Right? Entonces now you say, bueno, I don't understand very well what is the utilization of this. Okay. In the example you see clear the utilization of this. Okay, property number 4. It's nice. When you have summation, and you have from K1 to M, but inside we have a constant, non-dependent of K, it's just a number 20, 50, 40. Entonces, just the computation of this is multiplication C times M. Example to understand this. Suppose the summation from K equal 1 and 20, and this is 5 times. So from 1 to 5. This is 20. 5 times 20 plus 20 plus 20 plus 20 plus 20. Professor, I don't understand very well. Okay, the first 20 is for K equal 1. It is. The second 20 is K equal 2. The third, K equal 3. The number 4, K equal 4. And the last one is K equal 5. It's obvious that 20 times 5 is 100, no? So what is the shortcut to do in 1 second? Your multiplication, this number times this number. When this is a constant, and constant is que do not depending of the index variable. And suppose another example is summation K1 to 5 of 20K. Oh, no. In this case, we cannot apply the property 4 because that depending, so this is different number. Make sense? Make sense? Make sense or no?
Yes.
Okay. Property 5, 6, and 7 is just a formula. I don't want to prove that formula. No, it's complicated, extremely complicated. Maybe I'm doing after in another lectures. Summation from K1 to M to the K. Property 6, summation from K equal 1 to N of the K square. O sea, 5 is for the exponent 1, 6 is exponent 2, and 7 is exponent 3. It's the most popular we use it in calculus. Okay, this is just a formula. Okay, is M times N plus 1 divided by 2. This is more complicated a little bit. M times N plus 1 multiplied by 2N plus 1 divided by 6. And this is no big deal. It's similar to the property 5, but you copy exactly the same, but it's a square. Unbelievable. Let me try to illustrate that formula. It's very, very easy. There one is history of the mathematicians. famous goes. Okay, when you have an elementary school, the teacher put to what's the time to the student adding 1 plus 2 plus 3 plus 4 plus to 100. And the student, the majority of the students are doing it that way. 1 plus 2 is 3, 3 plus 3 que this is 6, and 6 plus 4 is 10, and so on. Because the objective of the teacher was the time. However, Gauss is a genius, doing it in different way. In 1 second, not 1 second, but in 5 seconds. He combined 1 and 100. To say 101. 2 and the previous 9 get 99. No? Again, it's the same answer. So you combine 100, 101, 2 and 99, 101 again, 3 and 98, 101, and you have 50 couple of the combination 101, and so you multiply 50 times 101, and the answer is 5050. Okay, this is the idea behind this formula. Look, suppose I adding the first natural number from K1 to 100. So in this case, N is 100 of K. Okay, so you expand this as 1 plus 2 plus 3 plus and the last one is 100. Exactly the same, this example. And you use the formula. No doing by hand. No. The formula say M, que es 100, N is 100, N plus 1 is 101 divided by 2. And when you compare 100 divided by 2 is 50, and 50 times 101, you get the same answer. Do you see, guys? Do you see? It's amazing, eh? Okay, so let's do an example. I bring a lot of, I don't know if we finish today or not. I suppose can. Okay. Example 1, to illustrate the property of the summation notation. Example 1. I want to do one by one. Only pay attention and ask me if you have any question. Compute summation from K1 to 5 of the 3K. So S sub K is 3K in our first example. But I see clear que 3 is a constant and you factor out outside. Using the property number 1. Let me show you. Parallel, property number 1. Property number 1 is a property. Look, the constant C, you put outside the summation symbol. And now, the rest, we have 3 times something, and we're using the property number 5. Okay, the property number 5 say, similar to the example that I explained now, okay, the 100, but not 105. So the 3 times multiplication by 5, multiplication by 6 divided by 2. Where I come from 5? 5 is M, who is 6, N plus 1, one more, and divided by 2. This formula, N plus 1 divided by 2. Entonces, actually, this is 30 divided by 2, 15 times 3, 45. Do you see this example, guy, or no? It's okay? Let me know. Come on. What happened, guy? Come on, more participation. Monique, Walter, Toralba.
I don't get that part. I don't get that part, Professor.
Okay. What part?
The 3.5.6 divided 2.
Look. You understand? Okay, these 3 you put outside the summation symbol. That part you follow me?
Okay. Yes.
Because I using the property number 1. Now I focus I focus in that summation. The summation in which you have only k, no k squared, no cubic. This is the formula. This is the formula. But in this formula, m is 5. This m is 5. And this m plus 1 is 6 divided by 2. And this is 30 divided by 2 is 15. And don't forget, of course, the 3 extra that we factor out, and 15 times 3, 45. Now, got it? Got it?
Got it.
Exactly. Let's move into example 2. Example 2 is more interesting. Here's summation from K1 to 20 of 5K plus 3. This is the, remember, you have the summation. This is a typical format. You have the summation symbol. We have two numbers, lower bound, upper bound, and here you have a sub k that represents a sequence. In this case, 5K plus 3. Okay, so you apply the property number 2, because for me it's much better split this summation in two summations. One summation is 5K, another summation is 3. And the limit is the same, 1 to 20. 1 to 20. But plus, no, because it's plus here. But I would like doing much better in that way. You put the 5 outside. And we focus in this, and we focus in this. This is exactly the same of this. 5 times 20 times 21 divided by 2. Do you understand where I come from 20 and 21?
Yeah.
Plus, and this is different because not depending of k is a constant, and this is a multiplication. 20 times 3. 20 times 3. And the rest is arithmetic. It's arithmetic. This answer is 1050. And this is 60, no? And together is 1110. Boom. Little by little, you follow me?
Yes.
Yeah, let me complicate a little bit. Example 3. Example 3 is summation from K0 to 14 of K squared minus 4. Oh, what is the new situation that bring me this example? Okay, any property that we studied before, we start in 1, not in 0. It's okay. It's okay. It's okay. How you solve that problem? Well, you separate, you evaluate in 0, so 0 squared minus 4. You separate the first element, and you have summation now. Summation from K1 to 14 of K squared minus 4. Do you understand this idea? So basically, this summation is given at the beginning, starting 0 and ending in 14. So now I put outside the gain, the 0 here, and condensing one more time this summation in only 1, but starting 1, que es like a natural way, starting 1 because the natural number starting 1. So you need to be aware that sometimes the summation starts in 0, sometimes. The majority, no. The majority is in 1 because the natural number. And 0 don't belong to the natural number, belong to the whole numbers. Okay? And never negative. Always 0 is weird. But the regular is starting 1. Actually, I focus 100% in this summation. But I need to remember subtracting 4. So actually, let me copy, negative 4 plus summation from K1 to 14, K squared minus 4, okay? So don't forget this negative 4, okay. So I copy, but I copy only now the summation que está en 1. I know that when I finish to compute this, I subtracting 4. So I recommend that you separate into pieces. The first piece is K1 214 of K squared minus another summation K1 214 of the 4, only 4. Because there are different formulas. The formula for the K square, I want to refresh your memory, recall is m plus 1 to m plus 1 divided by 6. This is the formula when it's K square. Look. Entonces, y la fórmula for the 4, que no depending of K, is the multiplication 14 times 4. That's it. Let's do it. It's easy. Look at that. It's n 14 in our example, times 15. Welcome from 15, n plus 1, one more. And 2n plus 1 is 2 times 14, is 28, plus 1 is 29. Divided by 6. Minus 14 times 4. Do you follow me, guys? Do you understand where I come from? 29, 15, and 14? And don't forget, and don't forget, well, just in case, I want to bring down this -4 que belong to the problem, right? Okay, the -4 I computed in this in my calculator is 1015 minus 56. Okay, the multiplication 14 times 4. Now everything together is 955. I don't know why the majority of the students I receive don't master the summation notation. So some teachers underestimate that part. And that part is super important in Calculus 1, in the last part of the Calculus 1. Example 4. We have time, yeah, we have time. We have 10 minutes. Suppose summation, I want to complicate it. Pay attention to this example, because we are. Summation for K equal 10 to 60 of 2K. Oh, look like easy, but however, it's not easy. The reason it's not easy is because that problem brings me new situation. Normally, the formula we have available is starting 1, K1 to 60, 2K. Oh, it's easy using the formula. You put it 2 outside, yeah, I understand. And you compute it using the formula que is 60 times 61 divided by 2. Oh, but in this case, no. So now, the recommendation, well, first of all, you put it 2 outside, okay. And you split that summation in 2 summations using the property number 3. Let me explain in detail, guys. Actually, suppose we have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. This is the summation. But the summation, our summation, start in 11 to 60. This is the summation that I want to compute. But I have no formula. I have no formula for that. I have formula when starting 1. So what should I do? You compute this. Okay, que is from 1 to 60 of the same expression. I just copy K and subtracting that part, the blue part. Que is from 1 again, pero to 9, to the K. Do you follow me? Do you understand this? When I explain that, a lot of people don't understand this. This is the new situation. So when the summation starts not in 1, when the summation starts in 1 is easy because we have formulas. But when the summation don't start in 1, so you need to split and 2 summations can start in 1. Look, in both summation now start in 1, 1, 1. But subtracting 1 because I want to remove the part from 1 to 9. Do you follow me or no?
Yes, Professor.
Okay, cool. No, fantastic. I teach yesterday, and no people understand this. Oh, I don't understand this. Okay, but you are smart. Okay, so now we computed this and this together again using the formula. The formula is 60 times 61 divided by 2. Yes or no? Minus 9 times 10 divided by 2. Wow. If you want, you cancel out that 2 if you want. And your multiplication is 60 times 61 is 3,660 minus 90, no? And the answer is 3,570. Oh. Be careful. Be careful when you have summation that do not start in 1. I need to modification to apply the formula. One more example, and that's it for today. Example 5. Example 5. Suppose summation from K4 to 24 of the KQB. KQB, I don't remember, Professor, the formula. The formula is KQB is m plus 1 divided by 2, exactly the same for the 1 exponent per square. It's the formula for the cubic. Unbelievable. Unbelievable. But it's not the problem. The problem is I apply that formula if my summation 2 KQB start from 1 to m. But no, F4. So I need to split this summation in 2 summation. 1 and 2 summation. This summation start from 1 to 24, that's a full. And this summation start in 1. Again, 1. I need 1 here. 2, 3. That's the previous of 4. And subtraction. KQ. KQ. Okay, let's apply the formula. The formula is easy. The formula is 24 multiplication by 25 divided by 2 squared minus 3 multiplied by 4 divided by 2 squared. Okay, so now this is put in the calculator. Square is a big number, is 90,000 30 minus, this is not big deal because 3 times 4 is 12 divided by 2 is 6 squared 36. And when you're subtracting is 89,964. Yeah, we have time. We continue one more. Guys, you follow me? Yes or no?
Yes.
Yeah, cool. Yeah. I told you the first time, this subject intensive. But no problem, because when you pass this class, you pass 2 classes. You pass college algebra plus pre-calculus. Okay, one more and that's it. Suppose from K equal 20 is the lower limit to 50 is the upper limit, and the sequence inside is a constant, do not depending of A. Oh, professor, you explain me que this is multiplication, no? Oh, yeah, es multiplication, pero es multiplication if, okay, I agree with you 100%. See, our summation starting 1, ending in 50, entonces now es 80 times 50. And by the way, a 40 and 2 more 0, 4,000. But in this case, no, because they are missing a lot of guys here, right? So what is the formula? Well, the formula is you subtracting 50 minus 20, es 30, no? Pero plus 1. Why plus 1, professor? Because how many numbers we have in between 20 and 50? We have 30, no, we have 31. Because include both endpoints. We include 20 and include 50. Entonces es 31. Es 31. So you multiply 31 times 80. And the answer is 2,480. Bueno, professor, I don't understand. Because here you don't adding 1, and here you adding 1. I suppose que yes, we are doing, pero you are doing, and you don't be aware que we are doing. Look, suppose que I am doing that way. 80, no, 80 no, sorry. 50, 50, 50, 50, minus 1, que 50 minus 1, no? Plus 1. Pero es que 1 minus 1 plus 1 is 0, entonces 50. So actually, you multiply 50 times 80. So I did, pero I don't be aware que in general, in between 1 and 50, we have 51 number. Include 1, que is the first one, and include 50, que is the last one. So in between 20 and 50, we have 31 numbers. Including from 20 is the first, 21 is the second, 22 is the third. Bam, 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 to 50. 50 is 31. Cool, guys?
Yes, Professor.
Excellent. So we continue Monday. Monday. I will send the test number 5.
With the final.
And the final, yeah.
And with Wednesday or Friday?
No. Es due. Let me check the calendar. Just in case I confirmation after that. Well, the last day. So this week, today is 12, no? Next week, we have 17, 19, no?
Yeah,
but everything is due 25th. 25th is the last day.
The last day for semester.
Yeah.
But do it before that.
Yeah, nice.
Okay.
Si you anticipate better. Entonces, my idea for you is next Monday, que es 17, no? I will send test 5 and final. However, everything is due, so the last date is 25th. After the 25th, I close. I don't believe in nobody. I close. I adding everything. I send. So I recommend anticipation because and confirmation. So you send me a test, so the answer, and you waiting for me. I say thank you. Oh, I got it. This is my common expression, no? See, no confirmation, you double checking. Professor, you receive yes or no, right?
Yes, I always do that. Yeah.
Okay, cool. So now, guys, thank you so much for your attention. Bye-bye.
Thank you, Professor, guys.
Bye-bye.
Bye.